would have got the answer. Correct? Now let us talk about the next heading, that is continuity. Now continuity of a function is very much connected to limits, and that is why I am discussing this area here itself. If you talk about from the gate perspective, it is not very much evident. Very rarely gate have asked questions on this particular topic, but yes, they do ask questions, so we cannot neglect this thing when we are preparing on a national level with and reputed institute like ICE. We have to understand that each and every topic is important for us, right? At least we cannot afford to leave a topic, because gate is a very unpredictable exam, so we have to understand how it could be taken care of, right? So continuity, what is continuity saying? What he is trying to say is whether the function is continuous or not at a particular point, whether the function is continuous or not, right? So if I say that for continuous, limit x tends to a minus, let's say, of fx, if it is equal to limit x tends to a plus of fx, which was basically the condition for limits to exist, can I say that function will be continuous? Just think over it. Pause the video and think over it. What I'm trying to say is, I'm repeating, if the left hand limit, the function's left hand limit means if you approach the function, let's say this is the function given to you, right, and you want this point, so you actually saying that if I approach this function from the left hand side and if I approach the function from the right hand side, right, and both the values are giving you the same, so can I say that the function is continuous at point x equal to a? At this point, is the function continuous? Yes or no? Always. Now you have to understand this particular thing. Now this is not the case actually. Try to understand why. See, this is not the only condition for continuity. Why? Supposedly you are saying you are approaching from left and you are approaching from right, you are getting the same value, right? What do I mean to say is, let's say you are approaching from left and you are approaching from right, you are getting the same value. I'll redraw it so that you'll understand it better. I'm approaching from right and you are getting the same value. Why you are getting the same value? Because the y coordinate is same, right? The y coordinate is same. Getting my point? But let's say this is your x equal to a point. At this particular point, if you get a spike, something like this, I just made it magnified, it is very small thing, then is the function continuous? There is a spike, or you can say there is an open spike, could be considered at something like this, this function become discontinuous like this, and I have magnified it. This is a very small region basically, but because h is a very small value which we discussed earlier, left hand limit we are talking about it's h, which is very small, infinitely small point, right? But if there is a spike at that particular point, then the function is not continuous, right? So what should be the actual condition for continuity? If you talk about the actual condition for continuity, should be that definitely the limit 0 minus fx should be equal to limit 0, sorry, not 0, x a plus of fx, and should also be equal to the function value at that particular. So this is basically the condition for function to be continuous. Getting my point? This is the condition which is important for solving problems on continuity. The function should be continuous if limit exists and the value of this should be equal to the function also. So if you, whether you approach from the left hand side or whether you approach from the right hand side, both ways you will have to say they should be equal and should be equal to the function value at that particular point. Clear? Now let's say, let us take it this with an example. I will give you a very simple example. Let's say it would given to you that the function is given to you, let's say fx is equal to x square, and you have to check continuity at x equals to 2. You have to check whether this function is continuous at x equal to 2. We actually know that this is a continuous function. Why? We know it's a standard curve. It is a parabola, right? It's a standard curve, right? Which is a parabola basically, right? Now, so parabola at x equal to 2 will be definitely continuous. But let us check it out, how whether it will be continuous or not, right? So let us say first we'll take the LHL, which is the left hand limit. So left hand limit will become limit x tends to 2 minus of x square. That can be written as limit h tends to 0, right? 0, not 0, a minus h, that is 2 minus h square, right? If I substitute h equal to 0, it will become 2 square, that is 4. RHL, if you'll find out, it is limit x tends to 2 plus of x square, that is nothing but limit h tends to 0, 2 plus h, a plus h, right? So 2 plus h whole square. Again, if I substitute the limit 2 square, that is 4. And if I want to find out f of a, that is f of 2, and that is nothing but 2 square, so that is also 4. So you can see these all three are equal. So can I say that LHL is equal to RHL is equal to f of a? Then you can definitely say that, hence you can say function is continuous at x equals to 2. If any of the values would have not been equal, then we cannot say that it is continuous, right? Now there can be 2-3 types of continuity. Let us discuss one on one types of discontinuity. Not continuity, I'm sorry, discontinuity. There can be, if the function is not continuous, we'll say it is discontinuous, right? So there can be 2-3 types of discontinuities. Number one, we will say discontinuity of type 1. Now it is very easy to understand these types of discontinuities. Supposedly for a function, for an fx function, the left hand limit is not equal to right hand limit. Can the function be continuous? Obviously not. In fact, limit is not existing at this point. So we can say this is this, you can say for this function, we will say that there is a discontinuity of type 1. There is a discontinuity of type 1, right? So the condition we can finalize is the LHL should not be equal to RHL, right? Now when you talk about second case, discontinuity of type 2, discontinuity of type 2. Now what are discontinuity of type 2? Let's say if for a function the left hand limit or the right hand limit or both does not exist, then the function fx has a discontinuity of type 2. Getting my point? What I'm trying to say here is either of the limits, either the left hand limit or the right hand limit, if they are not existing or both are not existing, then this is a discontinuous function and this is a discontinuity of type 2. Where you will find this thing, practically speaking, you will find this on boundary conditions. See, let's say for example this is a wall. At this point, if I say I have a left hand limit, I have a right hand limit, I can find out. But what about this point? This point, I only have a left hand limit. I only have a left hand limit. There is no existence of right hand limit. This is vacant, right? So at this particular point, the function will become discontinuous. You can say discontinuity point, or you can say discontinuity of type 2. Of type 2. Clear? So we have categorized into a different domains, right? Let us talk about the third type of discontinuity now. We have talked about the first type, which was saying limit does not exist. LHL is not equal to RHL. Second type, we are saying LHL do not exist or RHL do not exist or both do not exist. Discontinuity of type 3. Discontinuity of type 3, or sometimes it is also called as removable discontinuity. Removable discontinuity. Now what are these? Discontinuity of type 3. Let us understand this particular thing. Let's say if left hand limit extends to a minus of fx is equals to limit extends to a plus of fx, but it is not equal to f of a. Now we say that basically in this case limit existing, but limit definitely is existing, but what is not existing is continuity is not there. This will be discontinuous. F of a is not equal, right? You know the condition which I told you, there is a spike, right? So in this particular case we will say it a discontinuity of type 3. So this is the condition for discontinuity of type 3. Clear? So these are the three types of discontinuities we can always discuss. Sometimes questions are asked on this particular fundamental also, right? One more type of question can be asked on basically continuity on multi-valued function. Let us discuss one fundamental of it. Put the next heading, continuity of multi-valued function. You know, for example, there is a function which is not defined in a single domain. You know, there can be multiple domain of that function. For instance, let us say there is a function fx, let us say, is defined as something like this. It's x square when x is less than equal to 0, 4x minus 2 when x is between 0 and 2, x square plus 2 when x is between 2 and 3, and for x greater than 3 it is 2x cube minus 43, right? The general function which I have taken, and you have to check continuity. Let's take this as an example. Continuity at x equal to 0, and 3. You have to check whether this function is continuous at x equal to 0, x equal to 2, or x equal to 3, right? So how will we check this particular thing? See, first we will talk about checking whether this function is continuous at x equal to 0. So I know that left hand limit, that means the value is less than 0 and the value is greater than 0 and the value at 0, function value at 0 should be same, right? Now if I say for 0, so for less than 0 and equal to 0, we'll take function value as x square and we'll substitute x equal to 0 in fact, right? So for LHL is equals to f of a, and we will say the function value will be x square, or we can say 0 square, that is 0, right? Similarly, you are checking for x equal to 0. Similarly, RHL means 0 plus, so we'll talk about this area. We'll take this as a function value, so we'll take 4x minus 2, and this is 4 into 0 minus 2, so it will be minus 2. So is the RHL equal to LHL equal to f of a? No. Which type of discontinuity this is? This is discontinuity of type 1. Yes, LHL is not equal to RHL, right? So discontinuity of type 1. Making clear to you now, right? So fx is not continuous at x equal to 0. So we can say fx is not continuous at x equals to 0. This is one statement you can make. We can say note 1, right? Then when I talk about checking it for continuity at x equals to 2, so you can find out LHL for left hand limit. See, this will be the LHL and f of 2, that is 4x minus 2. So for LHL is equals to f of 2 is equals to 4x minus 2. So nothing but 4 into 2 minus 2, that would be 6. Okay. And talking about RHL 2 plus, which will be this case x square plus 2. So for RHL we'll use x square plus 2. So this will be nothing but 2 square plus 2, and that will again be 6. So now LHL RHL equal to LHL equal to f of 2. So we will say the function is, so the function is continuous at x equals to 2. You can say this is note 2, right? This is continuous. Similarly, we will check it for continuity at x equal to 3. How will we check continuity at x equal to 3? Let us go back to the function. For less than 3, it will be x square plus 2. And for RHL and f of a, we'll use 2x cube minus 43. So for first of all LHL, it will be x square plus 2. So that is nothing but 3 square plus 2, and that is 11. For RHL equal to f of 3, right? Both are giving you the same value. So it is 2x cube minus 43. So the function is 2x cube minus 43. So substitute 2 into x is 2 cube, not 2, 3. It's 3 cube minus 43. So it is 54 minus 43, which will be again 11. So can I say again the function is continuous? Yes. RHL is equal to LHL is equal to f of 3. So we can also say, so the function is continuous at x equal to 3. See, in a paper you need not to write everything. I'm just writing just for the sake of you understanding the fundamental. In a paper you can directly check it out. You will find many questions on this particular fundamental of checking, right? And you can easily connect this and you can say that. So finally you can say that x is continuous. For example, if the options were like continuous at x equal to 0, 2 and 3, continuous at x equal to 2, continuous at x equal to 2, 3, and let's say the fourth option is given continuous at x equal to 0 and 3. So what is the option you are going to take? We are going to take option is 2 and 3 only. Correct? So you got the concept how we will be